Hello friends, in today's lecture we will discuss about load calculation during appending or flipping operation using the cranes. Okay, now we will understand what exactly is appending or flipping operation first. So, okay, suppose we have this element. Okay, the element in front of you is basically a coal plant element or the coal plant part, that is basically slurry heating equipment. Okay, this equipment is basically cylindrical in shape and we have to do its erection vertical. The installation is basically vertical. Okay, such operation where we have to do the vertical installation. Suppose there is also bridge gantry. If you have seen the bridge gantry legs are assembled in the form of A over the ground, then this A is particularly lifted up. Okay, and do the vertical A from the horizontal A to the vertical A erection is being done. Okay, such an operation are called as appending operation or flipping operation, and there are basically two cranes are used. It is a special case of tandem lifting. One is the assisting crane, or this crane is also called as tailing crane, and the other crane is basically the main crane, and the final installation is basically vertical position. Okay, it is clear. So here we will discuss about this operation. So this is the picture that I got from net. Okay, this is one of the main crane. This crane is the main crane, this one crane, and this is the assisting crane, or basically the tailing crane. Now here you observe one thing, very important thing. This is the CG line, that this is basically the CG. One lifting point of the main crane, the lifting point of the main crane is passing through the CG, but the lifting point of the crane is at a distance d from the CG. It is not is at this CG. Why such arrangement is being done? Okay, we will analyze this, and we will analyze and we will observe what are the consideration we have to taken during lifting operation. Okay, and it is a very important observation, and if you know physics, then only able to understand it. Okay, now this is the case. We will convert this into a simple case. Okay, this is the first case where this RB is basically the main crane. RB in both cases the main crane. RA is the assisting crane or the leading crane or the tailing crane. Sorry. ठीक है, R is the assisting crane or tailing crane. Now in both the cases, one lifting point is at a distance B, other lifting point at a distance A, same. But the difference is that this lifting point RB is at the center line. Here it also at the center line. But in this case, RA lifting point, the crane A lifting point is at the center line. But this RA, or in this case, it has a distance D from the center line. It is not at the center, it is a distance D from the center line. Okay, this is the case. When we are doing the just normal lifting, or we are doing just tandem lifting, okay, when there is no tilt, we are just doing the horizontal lifting. We are lifting horizontally. Okay, this element is just lifted like this only. Okay, in such a case, if you want to calculate load using the lever principle, then RA comes out to be opposite distance divided by opposite distance into total load divided by total distance. RB same come out opposite distance into total load divided by A plus B. Lever rule, simple lever rule. Okay, you understand? In the lever rule, we have to apply the perpendicular distance between the line of action of the forces, and that we follow. Lever rule, it is simple. There is no need to explain it in much detail. Okay, so here we are able to find RA, RB, RA, RB. It seems that there is no need to worry when the lifting point is at the center line and the lifting point is at the top, but there is some concept we will understand now. Now we are lifting it at some angle. Okay, now we will do the another case where we are lifting it at some angle theta. This is the angle theta. This is a simple case again where both the lifting points are at the center line. Okay, in such a case, if this is the angle theta, yellow one, this is the angle theta. I always told you in the lever rule we have to take the vertical distance between the line of action of the forces. इनके बीच का vertical distance we have to consider only. Okay, now this is B. If this angle is theta, then this comes out to be B cos theta. Similarly, this angle is theta, so it comes out to be A cos theta. Similarly, you can see this figure. This is hypotenuse. this is perpendicular and this is base, and we have to focus on the base. So cos theta is equal to base over hypotenuse. So in this way base comes out to be b cos theta. Similarly either this here comes out to be a cos theta. So again applying the lever rule, the line of action, we found the perpendicular distance, again lever rule, Ra comes out to be w into b cos theta or a cos theta plus b cos theta. So we can write it a plus b cos theta. Similarly Rb comes out to be Rb, opposite is a cos theta, so w into a cos theta or a plus b cos theta. So it is a simple case, there is no much complication. But in other case we will understand. This is the another case where the lifting point is not at the COG line, it is at a distance d from the COG line. We will draw it to the maximum. Okay, this is basically at a distance d from the COG line. Now I will make the marker point some thinner. Okay, it is clear. Now here the case, now the total distance, this distance total comes out to be this. Okay, the previous distance, that is a cos theta, this is a cos theta, but we have to add this distance also because the line of action shifted, okay, because of this lifting point, at the top at a distance d from the center line. So this angle is theta, this is 90, so this angle is 90 minus theta, this is 90 minus theta, so this is also 90 minus theta, and this angle is already 90, so this angle becomes theta. Again this is 90 minus theta, this is 90, so this angle is theta. In such a way this angle becomes theta. Sin theta is equal to perpendicular over hypotenuse. Perpendicular is this, the distance that we require, okay, this distance. So perpendicular over hypotenuse, so p is equal to d sin theta. So what addition is done over here? A cos theta plus d sin theta, this addition is being done, and b cos theta. So again using the lever rule we can simply calculate Ra is equal to this b cos theta over a cos theta plus d sin theta, and सबको add कर दिया some total length. Okay, similarly this factor into w divided by total factor. Now you can see two results are there in front of you. When we are doing the this tailing crane lifting point at the COG line, then the equation is this. Okay, now when we are lifting the tailing crane at a distance d from the COG line, then the equation is this. So what we observe from this equation, when theta keeps on increasing, the load on the assisting crane or the tailing crane keeps on decreasing, and load on the main crane keeps on increasing. Okay, so this is the case, in such case where it is at a distance d, when the lifting point is at a distance d. Okay, as theta increases, load on the assisting crane or the tailing crane decreases, and load on the main crane keeps on increasing. This is the case over here. Okay, but if we talk about the other case, if we talk about this w into b cos theta, so here what happens, basically this factor is almost equal. Here Ra is equal to Rb. There is an equal distribution of the load, or we can say that this equal distribution means the load is not exactly equal distribution, but it is same. The value of Ra keeps on same, the value of Rb keeps on same. As the theta increases, the Rb and Rb, Ra is equal to Rb almost. Okay, and when the theta comes equal to 90 degree, then suddenly the Ra becomes 0 and Rb completely, the full load transfer to the main crane. Here there is basically sudden transfer of load. Okay, here basically sudden transfer of load. If we plot the graph over here, initially in this case where the tailing point, we are considering the case, this is the case. If I draw you in better manner, this is the case. If this is the COG line and we are taking lifting point for the assisting crane at a distance d, or at a distance d from the center line, then what happen, the assisting crane, as initially the load is equal on both the cranes, 50-50, but as the theta increases, this is the theta increasing, keeps on increasing, then what happens? Basically, the load on the assisting crane keeps on decreasing, okay, and the main crane keeps on increasing. There is a gradual transfer of the load. There is a gradual transfer of the load. But if we consider the case where the assisting crane lifting point is at the COG line, then initially both will take equal load, equal load, equal load, unless and until as theta is equal to 90, theta is equal to 90, the load on the assisting crane drops to 0, but load on the main crane increases to maximum. So there is a sudden. So what is the preferable method? The preferable method during upending is that we have to, in the assisting crane, the lifting point is always at a distance d or above, or a distance at a distance from the center line. We never take the lifting point of the assisting crane at the center line itself. Hope you like this video. Keep support and subscribe. Thank you.